everybody. Welcome back. Hope everyone's doing well. Today we're going to look at the second lesson in set theory unit. Yesterday, or the first lesson, whenever you looked at it, was really just about the introduction to set notation and really a lot of vocabulary in there. So remember, we used the terms element for an individual piece. Set is all of the elements put together. Subset is when one set is completely contained in another. Disjoint is when two sets have nothing to do with each other. And the complement means what I'm not looking for. Okay, those are your prime definitions so far. I would, again, maybe write those down somewhere. I know they're in your books, but it's good to have them maybe on a separate list written down. Okay, today what we're looking at is a short lesson on Venn diagrams. Now, you have probably, again, seen a Venn diagram. We use it a lot in social class, which I find is interesting. A Venn diagram is just simply a good way for us to display information in an easy form. Okay, so we're always going to have a couple, 2 or 3 sets that we're looking at. So we've got set A and we've got set B here. Okay, again, the importance of knowing this definition, they're both whole numbers. So remember, a whole number starts at the number with the hole in the middle, 0. So whole numbers that are divisible by 3. So 0 is divisible by 3, 3, 6, 9, 12, 15, 18. Whole numbers that are divisible by 5 that are less than 20. So I'm not going to include 20 because it says that it's less than 20. So don't put that 20 there. We don't want it. We want it less than 20. Okay? So you should always list your sets out. It never hurts to list your sets, even if the question doesn't ask you to. Okay, so the first question says, list the elements that are in both A and B. So I'm just going to go and I'm going to circle those. So what's in both of them? Well, 0 is in both of them. And 15 is in both of them. That's it. So the elements that are in set A and B are 5 and 0. Done. Easy. That's an easy question. Okay. I don't think it would be as easy if we hadn't drawn the sets out. So always draw out all the elements. Okay. What this is called is the intersection. This is where the two sets overlap. Okay, so it's the sets of elements that are in both A and B. Now we have a notation for this again. This is our notation. Remember, our subset symbol was kind of like an elongated sideways looking C. This looks like the same symbol, just pointing downwards. It means the intersection. And, okay, that's on my formula sheet. You should know that. Okay. B says, let's list all the elements that are in A or B. Okay, so what this means is I'm in A or I'm in B. So really, I'm going to go and think about my two sets again here. Things that are divisible by 3. So we had 0, 3, 6, 9, 12, 15, 18. And then we had our second set, set B, numbers that were divisible by 5. Well, I've already got the 0, so I'm not going to write that again. 5, 10. I've already got the 15. I'm not going to write that again. And remember, I'm not going to include the 20. That would be a little mistake. There it is. So do you notice A or B? It's all of the elements in both the sets. This is known as the union. Think of, again, a union in real life. A union is a group of people that are working together. So typically you're getting bigger. Typically you're getting bigger. Not always, but usually you're going to get bigger. Okay? So really, again, we're combining the sets together. And this is the easiest one to remember. It looks like a U. That's convenient. U for union, right? Okay, now what I should always do on these questions is draw a Venn diagram. Okay, list my elements and draw my Venn diagrams. So we had two sets here. We had set A, which was divisible by 3, and we had set B, which was divisible by 5. And then what I'm going to do is I'm going to write the elements of each of these in their respective places. But remember, right here, we had two numbers that were in both, right? The two numbers that were in both, that were divisible by 3 and were divisible by 5. So the two numbers that were divisible by 3, well, we had 0, and the two numbers that were divisible by 3 and 5 was 15. Okay, so that's our overlap, that's our intersection. Okay, the elements that are simply divisible by 3, but not divisible by 5. I'm going to write there. And the elements in B that are divisible by 5 only. Oh, not the 20. See, I did that a couple times, didn't I? There you go. Okay, so what we've got here is a really easy way for us to demonstrate or display more than one set. Okay, most of the time we'll have 2 sets, but we will go up to 3 sets. So we will have 3 Venn diagrams, but that's another lesson, not today. Okay, so in general, at the bottom of your page here, this is really, really important. Okay, this area in here, I'm going to make my line a little thicker and let's make it bright yellow. This area right here, that is the intersection. That's A and B. And the other way to write that is A intersect B. Okay, those are the elements that are in A and the elements that are in B. Over here, I'm going to change my pen to pretty purple, and let's make it a little thicker again. This area over here that I'm highlighting in purple, everything that's in there, that right there, that is the purple section, is the elements in B only. Okay, that's B only. They're not any overlap with A, B only. And on the other side here, let's go for pretty green. Right in this kind of moon-looking shape right here, that is elements in A only. So these are the guys that are only divisible by 3. Okay. Now the whole thing put together. So I'm going to change my pen color to, I'm going to try this maroony looking one. A or B. A or B. I'm in A, I'm in B, or I'm in both. A or B is both circles shaded together. So the new shade right there, A or B, also known as A union B, is both circles put together. Okay, so again, usually unions we're getting bigger because we're adding elements together. Not always, but most of the time we're getting bigger. The intersection, think of it as where 2 streets cross. They're not going to cross in a lot of places. So usually we're getting smaller. Okay, now we got one more little section there that we need to talk about that I think is one of the easy spots to miss. This arrow down here at the bottom, do you see it? Okay, What does that represent? Well, that's the elements that are in neither A or B. Okay, so these people out here in this region, this is the elements not in A or B. They're not in A or B. Okay, so there are other numbers out there. So if we think of the whole numbers from 0 to 20, there's other numbers we could put in there, right? Okay, so these are the numbers that are not in A or B. Okay, now the other way to write that is A union B. And we put this little, remember right there? That's the complement, the prime. I'm not in A or B. So if we go back up to the example we had before, let's scroll back up here. And we drew A or B. Again, here's A, here's B. And we had these numbers. So the two numbers that were divisible by 3 and 5, that was those guys. And we had these ones here, divisible by 3. So 3, 6, 9, 12, 18. And over here, we just had 5 and 10. Okay, but if we're considering the set of numbers from 0 to 20, guess what? Out here on the outside, we're missing some numbers. 1, 2, 4, 7, 8, 11, 13, 14, 16, I'm running out of room, 17, 19, okay? These are the elements not in A or B. They're not divisible by 3 or 5. Okay, so we always want to make sure that we label that region. Okay, it's really important. It's very easy to forget in a question because we're focusing on what's A and what's B, but it's really easy to forget that region. Okay, my friends, that's it. It's a short lesson for today. It's probably nothing too new to you. You've done it before, just like I said, usually we do it in social, which I think is really neat. A lot with political ideologies or how different theories overlap each other. But now we're doing the same thing in math. We're just putting some numbers to it. Okay, my friends, I hope that worked for you. Talk to you soon. Bye-bye.